So let's use Huygens and his principle to derive Snell's law for refraction. So remember, with Huygens' principle, we have two rays of light coming in at an angle. So you might remember how we looked at reflection. We had two rays of light, same thing here. But instead of obviously the light reflecting from the surface, the two rays of light are going to refract in the material. So here we have two rays, ray 1 and ray 2, both coming in the material. Ray 1 strikes the surface at point A. At the same time that ray 1 strikes the surface at A, we have ray 2 that is located at point B. The angle that ray 1 strikes the surface is going to be called theta 1. This is the angle of incidence. Now that theta 1 is also the angle that if we connect 2 points A and B, remember they're at the same time on rays 1 and 2, that angle theta 1 is also the angle that connecting line makes with the material. After some time delta t, we have ray 2 that is at point B and it will eventually strike the material at point C. Now while ray 2 is making this extra distance from B to C, ray 1 has travelled from point A and it has travelled to point D. The angle that ray 1 now makes when it's travelled from A to D with the normal is going to be theta 2, and this is what we would usually call our angle of refraction. Now this theta 2, remember, they're at the same time, so if we connect points at the same time, instances, we connect points D and C, and that angle theta 2, you can see on the diagram there, is the angle that line makes with the surface of the material. Also, it's useful to note that the two wavelets, the one at C and the one at D, are in different materials. Their wavelengths are different, therefore the size of their wavelets are different. And now we have our two triangles again, our two congruent triangles that share the same side. We have the triangle ABC with the angle inside theta 1, and then we have the triangle ACD with the angle theta 2. Therefore, we know that sine theta 1 equals BC divided by AC. And then sine theta 2 equals AD divided by AC. So we have AC, which is similar between both of our formulas here. Now, the distance BC will be speed multiplied by the time it took the ray or ray 2 to get from B to C. Now it is in medium 1, which means we can label the velocity as V1. Now for ray 1 that is traveling from A to D, it has a different velocity because it is in a different medium. Its velocity is going to be V2. So between the points A and D, ray 1 traveled a distance V2 delta t. So we can simplify this equation by saying sine theta 1 divided by sine theta 2 equals V1 divided by V2, because our delta t's cancel and the distance AC cancels. We also know that V1 equals C divided by N1, or N1 equals C divided by V1, and same thing with V2. So we can sub both of these in. When we simplify this, we find that sine theta 1 divided by sine theta 2 equals N2 divided by N1. And then this simplifies to Snell's law, which is N1 sine theta 1 equals N2 sine theta 2. And that's Snell's law of refraction.